Assalamu alaikum everyone. Today is your day 69 of your foundational computing course. We will be discussing today about the classes and objects in object-oriented programming. The language will be C++. The prerequisites for this topic is basically that you must have some simple knowledge of object-oriented programming, OOP, which you basically you'd have studied in the day before, like the day 68. So that is really important for the foundational basics. And now you are on to the OOP principles. So this OOP principle, the classes and objects, is really important for all of your next topics in all of the other days. You can say data structures and algorithms, your inheritance, polymorphism, every single topic will be based on the topics that we will discuss today. I hope that you will be able to understand these topics and you will be able to implement them easily. We will easily go through all of these topics. There will be nothing hard in these topics. There will be just a basic introduction for you into the classes and objects world. So let me open the slides for you guys. So first of all, for all of you, why are classes and objects needed? Okay, why are they needed? So basically, classes and objects, they are used to map the real world objects. So basically, in the real world, you have many objects. You can have a car, you can have a player, and these things are basically mapped using a class and object. So there might be other uses that you can say. So basically, a class is like a cookie cutter, which will define the shape of an object. An object are like cookies; they are basically the instances of a class. So you can have many types of cookies. You can have a chocolate cookie, you can have a peanut butter cookie, so they are basically the instances of an cookie. Another way I can explain this topic to you is that classes are basically the blueprint of something. They will basically define what is in a class. They will basically define what is in our objects. For example, when we talk about a player, we always talk about what is the name of the player, what is the age of the player, what is the height of the player. For anything we can take as an example. And you might have studied, you would have studied by now. I'm expecting that you would have known the data types in C++ or in any language. You would have studied int, you would have studied, for example, double, float. And in that, when you write a program, you basically make a variable. You say int x, int number, float number, your string name, anything. That is basically an instance of that data type. So classes are basically a user defined data type. They're nothing more than that. They're basically a user defined data type which have member functions and which have member variables. About this, we will study in detail in the next slides. So next we come into classes in C++. Okay. So I will make the screen bigger for you so you can understand this. So this is basically an example of a class in C++. I have given you a basic template of this. So you have a class over there. The keyword used is basically class. So you can put this in a header file or in CPP file. We will study this in the next slides as well. So you make a class. Okay. For now, just forget that where we put this in the code. Just see at the basic syntax of a class. This is the basic syntax. So you have a class, the name of the class, whatever you want to name your class. You can name a player, anything you want to name, any real world object you are mapping. You can name it as a person. So then you have these access specifiers, the keywords, the private specifier, the public, and then you have this private specifier indeed has the private data, they have the private member functions, and then this shows the member functions or the member data variables, which are basically public. And then you have got the this is the basic syntax of a class in C++. We will study this at the end. I will show you some programming concepts which will help you to solidify your concepts of classes and objects. So now we come on to the class data members and member functions. The data items. So for example, like in the class foo, you have made a data member of int data. So in a class player, you might name string name, you might keep it as int age or anything. Those are basically called your data variables, your data fields, your data members, your instance variables, anything you can, but they are basically your members. So do you understand what they are? They are basically something which are defining the state, which are defining the state of someone. So when you're defining a player, you must always know the name. Or when you're defining a car, you must always know the color of the car, the brand of the car, the model of the car. So these are basically the members of that class. So any class you take, they have basically always have some members. Okay, then you have member functions. So in member functions, you can basically talk about a player. So in a player, you can have the member function of get the score of the player, or you can in a car you can say drive or recharge or refuel. Any example of a member function is basically those are the functions. Okay, one important concept to remember is that functions are usually made public. It is a very rare instance that we will make them private, but we do make functions private as well. But mostly we make them public. The data members are usually made private, which I will explain to you in the next slide as to why they are made private. Okay, classes also contain a special function which is called a constructor. Okay, always remember that you create an object of a class. First of all, you create a class, and then in the main, you basically create an object of the class. When the object of the class is created, a special function is called, which is called a constructor. That constructor may be default. That default constructor means that the one which you do not code in your program, that is basically called by the compiler. That you will learn by the end of this lecture. But there's another constructor which is called the parameterized constructor. That constructor, as we will go on in the slides, you will learn that that is something you code on yourself. So a constructor is basically which initializes the values for a class. So for example, you have made a car class. In that car class, you have the name of the class, you have the model of the class, you have the color of the class. And when you create the object of the class, for example, I go into the main, I say car Tesla, and I create the object. Now the name of that class I'm gonna pass in my from the main. I can pass basically the model of that car, and then that is going to be initialized in my parameterized constructor. A lot of this is just the minimal information that right now you need about the constructor. We will discuss this further in the slides. Now let's move on. Object creation instantiation. A constructor will always be invoked whenever you create an object. So for example, the syntax for something, you're creating an object in the main class. So I have given you an example. You have to mention the class name, and then the object name you have to use. So in this case, I had a class student. So I wanted to make the object as my student. So I just make it. So basically, for example, if my code had no constructor written by me, it will call a no argument constructor. This no argument constructor is also called a default constructor. That default constructor will obviously initialize with the default values. The default values will, in this case, will always be, in case of int, it will be 0. In case of string, it will be blank. And in case of float, it will be 0 0.0. Nothing to be here. So now when you call student my student in basically a main program, you have basically created one object of the student class. You have created one object of the student class, and that object basically goes into the memory of your computer, and that is saved over there. Now, as I've written also in the slides, you can see that the constructors can also take parameters. We will discuss them about a little late, okay? Now becomes the object member access operator. So basically, after you have created the object, you can call the data members of the class, which are obviously public, which should be public. If you want to call a data member or any function, those should be public in your class. If their visibility is private, you cannot call them directly. They can only be called in the other functions of the class. So for example, right now you want to call, for example, you created an object of my student, as we discussed in the previous slide. So now you want to call the name of that data field. So you say my student dot name. Okay, then you created a function, for example, in student calculate GPA, or you created a function get attendance, or you created a function about print anything. So you basically call it from the syntax used below, my student dot print, and you use this syntax in order to call the function of your class. So now my student is basically the object which will use the functions of the class, and that this instance will basically call those functions which are obviously public. You cannot call the private functions. Now we will discuss this by the end of our lecture. the object creation and everything. Now we are basically on one of the most important principles of object-oriented programming. I am sure by the point that you are learning this lecture, that you are viewing this lecture, you must have known about what are the objectives of object-oriented programming. One of the major objective of object-oriented programming is basically encapsulation, which is basically called data hiding, which is data hiding. But the real question everyone asks, how do we do data hiding? How do we encapsulate our data? That is basically encapsulated in a class, and then we use different access specifiers, as I've already told you about the private and the public access specifiers. And there's also one more which is called the protected specifier, which we will learn at the later end of this lecture. And then obviously, how what does data encapsulation mean? What is data hiding? Who are we hiding the data from? Basically, we are hiding the data from the parts of the program which do not need to know about any information about this. So for example, you created an object instance. The object instance should just initialize the name. It shouldn't know what the name was before. It just should know that you have just named it. Or for example, you're someone who's seeing a screen on it. You should not know how did you program it on the back end. This is basically called encapsulation. That is called hiding. As I've mentioned over here, data hiding means hiding data from parts of the program that don't need to access it. More specifically, one's class data is hidden from other classes. For example, you've got a player class, and then you have got a team class. The team class should not know a lot about the player class. They should not know what the data type of the player, the name of the player is, and different things like these. Okay. Now we come to the access specifiers. So access modifiers or access specifiers are used to set access levels, basically to do encapsulation. We use access specifiers, which are basically public, private, and protected. Okay, you have to always remember that the default accessibility level in C++ is private. So for example, when I do not mention any access specifier, that is, I do not mention whether my member function is public, it is private, it is protected, the C++ will suppose that the default for that is private. Okay, now you have the mukhtalif, you have the different access specifiers, their information. The public is presents clients with a view of the surfaces. The class provides interface. Data member functions are accessible. So the data and member functions in case of public are going to be accessible from anywhere in the program. So basically, you are in a main of the program, you can basically access the name. If you have made the data member a public, you've made the data member a public data member, so you can access it from anywhere in the program. But if you go to private, you cannot access it. You can never access that data member if you made it private, or you've made the member function private. The protected is basically accessible within the class they are declared, and derived classes. So basically, derived classes, you will obviously learn about them in the next lecture. They are basically, you use inheritance, so I will not dive deep into that. You will learn that in the day 70 lecture. So now it becomes the private member function. The private member functions are basically only callable from the functions inside the class. So for example, you made a player class, and in that you made a private function named score, and then you can only call that function in the other function of the class, known as, what you can name it print, you can name it visualize, anything you want to name it. You can only call it from there. The direct access to this class is not possible. This member function is not possible. So for example, if you create the object of that class, you cannot call it. So for example, this is a very simple code. This is a very simple code for your understanding. You made a private member function display area. This display area is called in the public member function of calculate area, as you can see in this code. And then you can only call this calculate area function in the main. You can call the calculate area because that is public, as you can see in the access specifier. Then you call it, and then in that calculate area, you basically call the display area. Why is this allowed? Because this is the same class, and in the same class you can call a private function as well. But if you called it in another function which is not part of the class, then the compiler would have not allowed you to run the program, and it would have given you an error. Okay, this is a simple program accessing member function. So for example, you created a class circle, you made a data member with private called double radius, you had a public member variable, you made a public constructor. Okay, remember one thing, you can make the constructor as private as well, but there's no advantage of that. So you always have to make the constructor public. Why? Because the constructor is always called whenever you create an object. So always remember this point. You are allowed to make the constructor as private, but there will be no advantage of that. You will be wasting your resources on that. And then you have created a member function called double get area, and then in the main you basically call that, you basically use that object and you call the get area function. Okay, now in this, remember one thing, you must see that this code line, that's the radius is not accessible. Why? Because it is private. What about if it was public? You should guess your answer, and you should know that in the case of public, that would have been accessible. You could have been able to set this to 20, 30, 40, any value, but in case of private, you cannot change the value if directly. You should create a function for that, and in that function you can pass this value, and then you can change the value of the radius, but in this case you cannot. Okay, now we are basically discussing the constant member functions. Constant member functions, they are basically the read-only functions which cannot modify the object's data members. Constant member functions cannot modify the object's data members. In the later part of the lecture, we will learn about the get member functions, the setters, and the getters. Over there, you must know that the getters are always constant member functions. They will never modify the objects data members. What do we mean by not modifying data members? For example, if I have made a function double get area constant, you would have not been able to modify the radius value to any value that you would have liked. So, but if I had made a normal function, which is basically called a normal member function, in that case, you would have been able to, what do you say, modify the value of radius. But in this case, you would not be able to modify that value. So this is an example given to you. The constant function you have created over here, you created a private the radius, and then in this example, basically you made the double get area a constant function. This is the same as before, but now in the circle you called the 8.0, you basically gave it a random value. Constant member function cannot update change object data. It will not change that data. Now we are discussing accessors and mutators, which are basically called getters and setters. Okay, uh, you have you must have been confused that, oh, why are four names being used? So remember that getters and accessors is one name, mutators and setters is one name, but mostly the names that we use in programming languages are basically getters and setters. Okay, the getters or the accessors are basically which are going to get your value for something, like what is the current width, what is your current length, anything, your name of the player, the age of the player, anything like that. Okay, now now the main concept over here is that why do we create getters and setters? What is the need for getters and setters? What does a setter do? A setter basically just sets the value of any data member as you would have liked it. For example, if I was creating a player and I wanted the player to be any American footballer, I would have named him LeBron James, and I would have called it from the main, and my setter would have set the value of that player, that specific object's player name, to LeBron James. That's the use of setter. And what's the name of getter? The use of getter is basically that you call the function in the main and you basically get the current value that you have set for the object's data member. Now, what is the use of the getters and setters? Why do we even create this? Can't we just create one function in which we basically set all of these? Can't doesn't the constructor do the same work? So these are basically used because your data members are usually private. So we use them to just get the value of them through the constructor. You can set the value, you can set the default values, but through these getters and setters, you can change the values, you can get the values. The question now for you to answer is that why a constant keyword is being used with get with. That answer is be that the answer is in the previous slides as well. But I hope that you get to answer why getters are being used with a constant keyword, but setters are not being used with a constant keyword, and why getters do not have any parameters while the setters do have parameters. This is something that you should question yourself about, and I hope that you get to answer these questions clearly. Now, this is something that I basically told you at the start of this lecture. that you have to basically differ between your interface and implementation. The code that I have written for you guys, which I will obviously discuss with you by the end of this lecture, also shows this thing, that basically the interface is separated from the implementation. So you basically made a header file in which you implement your class, and implementation is basically a CPP file. Header file is .h file, implementation file is .cpp file. The .cpp file, in that .cpp file, you basically call the functions of your class, you make the object of the class, but in the header file, you basically make the class. You basically give the what you can say about the blueprint of the class, or you define the class, whatever you want to call it. Now, this is an example that I'm giving you. You basically define the header file of a class. It is time1h. You in this you might see that the private is basically int hour, int minute, int second. This is set to according to 24-hour format. Then you have the class time, which says public, and you have the constructor, the default constructor. You have the set time, you have the print military time format, and the standard time format. Military time format is basically the 24-hour time format. So for example, that if you are in the evening and the time is basically 6, so basically you will basically call that 1800 hours, something like that. And this is the military format, and standard format is basically 6:30 p.m., something like this. Is the header file you have defined. Now this is the dot preceded with underscore. Okay, let me tell you something. You don't have to use these two functions as well. If these two calls as well in your program, you can simply use pragma once. I will show you that the programming assigned in the programming practice that we have at the end of the lecture. And then you basically have this main file. In the main file, you're obvious. I'm supposing that you have already got some familiarity with the C++ syntax by now. You must know what a ternary operator is, what the if else statements are. The statement that you see in the set time is basically a ternary statement, and this is basically works like an if else statement. You have this is something in this one, in this code piece of code, we basically just gave the blueprint of the class. In this piece of code, what we did was basically we defined every function that was inside this code. Okay, this is not, what do you say, necessary to do. What you can do, what I usually do, or what the most of the programmers usually do, is that they basically define the functions usually in the header file they make. So you don't have to go to the CPP file and just make the and just define the functions over there. This over here is basically called out of line definitions, and this is called in. And if I had defined them over here, this would have been inline. The inline example that you can see, this is basically inline definitions, and then you come over here, this is out of line definitions. But I will prefer that you basically define them inline. In that way, it is much easier to find the code and take out errors from there. Now you basically define this. Okay, you must have seen that in this code piece of code, I included the header file. Why? As you include the iostream file, in the same manner, you have to include the header file of the class that you made. So here I made the time class, so I had to include that header file, whatever the name of the header file was. Now we are on to something really important, that is constructors and destructors. We will discuss them in a little bit of detail. Always remember, this whole course is designed to strengthen your concepts, your foundational concepts. Maybe we will not be able to cover the advanced topics, but these foundational concepts are really important for you to go on and learn the other concepts after this. If you get good information about the classes and objects concepts, only then you will be able to learn about inheritance. And if you learn about inheritance, only then you will be able to learn about data structures and algorithms. Often you would have learned by now that data structures and algorithms are the most important topics. But remember, without classes and objects, you will not be able to learn data structures and algorithms. No matter how hard you work, no matter what you do, you will not be able to learn data structures and algorithms if you do not learn classes and objects the right way. If you do not if you do not understand these concepts. So this, it is very important to understand these concepts clearly. So now we are on to constructors. As I have defined, okay, this is a whole definition. I have given you a overload of definitions, as you can see. So this is basically When is a constructor called? What is a constructor? As I have defined you previously, a constructor is basically a special type of a function in a class which basically helps you create an object of the class. It is basically initializing the data members of the class. For example, you had a class car and you wanted to initialize the data members. You made the name of the car, the model of the car, and you called it from the main. And now it basically initializes those. So you might have known that you can overload constructors. You can have parameterized constructors. You can have multiple parameterized constructors. You may ask, how is that possible? That is by basically in one constructor you might just initialize the name. In one you might just initialize the brand. In other you might just you might have no parameters. One you can have two parameters. In one you can have three parameters. In one you might have none of the parameters. That is basically a default constructor. The one with no arguments is basically a default constructor. Now we are in constructor properties. Must have the same name as a class itself. A constructor always has the same name. So for example, if you have a class player, it must have the same name as a player constructor. It does not have any return type. Remember to never make this mistake. Never give a return type with a constructor. It basically initializes the objects. Now, object construction with arguments. The syntax to declare an object using a constructor with argument is this is basically your syntax. You have to mention the class name. For example, you had a class player. You mentioned the class name player. Your object name is basically, I can say basketball player or cricket player. And then in that, you can basically mention the arguments. For example, I've given you an example. The circle object is being created where the circle class object is being created. The circle is the class, circle one is the object, and you basically initialized it, or you basically called the constructor which sets the radius to 5.5. Now initializing objects, you have the default parameters in constructor. This is a default constructor, by the way. The int is equal to 0, whatever you hour, minute, second, set to, this is a default constructor. Now, and now this is something that you have already done. Now this is how you're going to call it in the main. You are basically setting the values different things, same constructor using overloaded style. This is the answer that it's going to give you. You can check out these codes in the slides, as I will attach the slides with you. Now coming to using the destructors. Okay, a member function in every class which is called when the object of a class is destroyed. So basically there is a proper chance that you might need to destroy an object of a class. So for example, you made a player a cricket player, but after some time you decided that I do not need this cricket player anymore. And the question that you might be asking in your mind, why do I need to delete this thing? I just made it. What effect does it do? This is related to your memory. Sometimes you do not want to waste your memory. Sometimes you want to properly use your memory. So you basically call a destructor just to delete that object from the memory. So now you have got free memory. The main purpose of destructor is to remove dynamic memory, perform termination housekeeping before the system reclaims the object memory. Acha. Name is basically tilde followed by the class name. In the constructor, you basically have the class name, a normal class name. Over here, you basically have the tilde symbol followed by the class name. No parameters, no return value. Only one destructor is allowed. Remember, you can overload the constructors. Make 6 constructors. The class and C++ will have no issues. But you make 2 destructors, C++ will have an issue. The destructors can never be constant or static. The last concept that I have mentioned, virtual, pure virtual, you will learn about this in the next lecture. So let's just skip it for now. This is not important now. For now, I hope that in the next lecture you are able to learn about this. Now, when constructors and destructors are called, constructors and destructors may be called automatically. So for example, if you have defined a default constructor, you do not even, you just make an object and then it is called automatically. In the destructor, whenever you leave the program, whenever you end the program, that is when the destructor will be called. Okay. Now we are going to discuss constructor and destructors calling. You have made a create and destroy class. I just made this class for you guys to understand this. You have the public create and destroy. You have that is a constructor. Then you have the destructor. You might be able to see that they have the same name as the class. Only the destructor has an extra symbol tilde. And then this is something you can define a destructor, but a destructor will never have any return type, same as a constructor. Okay, this is something you called, and then this is it will return to you. You might have seen that this is how your destructor is being called, and you might see something over here that the destructor is always called in reverse order. So for example, if the object 1 was the first one to be made, it will be the last one to be destroyed. Why? Because the memory, as you might have learned by now, works as a stack. And you will learn about the stack in the next lectures as well. So I hope that this part of the code becomes more clear to you by then, inshallah. Now, when do constructors get called? They are classes object creation time, dynamically allocated object. We will learn about this a little bit. Class argument passed by value, class object returned by value, object array element created. I guess the most important thing, all of these points that you have to learn is that whenever you create an object, your constructor is called. All others are just basically the same thing that the first point mentions. So I guess do not get confused. Just remember, whenever you create a class object, your constructor will be called. What constructors do? They basically initialize class data members, they allocate any needed resources, they allocate memory for dynamic members, they will obviously allocate memory. It's the same thing. You're allocating memory, you're initializing an object. At the end of the day, they're basically same thing. You're basically initializing things. So this is something constructors will do. Now what are we going to discuss next? It is basically the static and the constant keywords and the this pointer and the pointers to the objects. That is something we will discuss as well. Okay, now we are on to something which I will say at this point it is important. It is something that you must learn, but I guess this is a good concept to learn. But keep in mind, till now, I hope that the classes and objects basic reasoning as why do we use them is now clear to you. You can define pointers to class object. For example, you have the rectangle class and then you made a pointer. You first of all, you made a class which is called a my rectangle, that is a rectangle object. Then you basically made a rectangle pointer. You just initialize the pointer, null ptr, anything. I'm at this point, I'm supposing that you have adequate information about what pointers are. Okay, I'm supposing this thing. Now you have the rectangle, you made a pointer to an object. Okay, you made a pointer to an object and then you assigned that pointer basically the reference of the object that you made. So for example, what you did, that you made an object and then you made a pointer of the class, and then they are both from the same class, and that pointer gets the reference of the object, and then you use that reference to call different methods of the class, that is set width, set length. You might be able to learn from here. Dynamic object creation, you basically made a rectangle pointer, then you basically made a dynamically allocated rectangle object. So over here we're basically dynamically allocating an object. That is on the runtime you're allocating an object. You made a new rectangle object, it called a default constructor, and then you basically set up the width and length. Over here you basically gave the reference of an object. Over here you basically dynamically allocated it. Now is reference to objects. Okay, this is a reference to object. You basically made a class. Okay, you have the class count, you have the set value, the print function, the private function. Over here you basically have the one object of the class, and then you made a pointer which basically had the create pointer to counter and create reference. The first is the example of creating a pointer to the counter object, that is reference, and then in second one you're creating a reference to the counter class, and then the counter object, as you can see over here. And now you become reference and pointers to object. It's another example for you. I will suggest that you practice this example, but as again I've said, this is an important concept, but the most important concepts you have most probably learned by now are the classes and objects. You're just toying with them now. You're just playing with them now. It is you playing with these as you play with toys. This is the example, the best example I can give you. Now we are now the third part. I think I have not taught you till now. This is basically a reference to a pointer. Okay, the first is an object. The second is basically a pointer to object. The third is a reference to an object. This is a pointer. This is a reference to a pointer. A pointer, a reference to object. This is a reference to a pointer. So in this, we gave a rectangle, a pointer, which had a reference and it was basically assigned this pointer. And then you can use it to change values as well, obviously, from here, get area and everything that you had already settled. Now, static class members. Okay. As I had told you that you have to create objects to access member functions. Without objects, you can never access member functions, and those member functions have to be public. But static member functions are basically those member functions and those class members which can be accessed by only using the class name as well. Yes, you can access by an object name, of course, but they can be accessed by a class name as well. What's the use of these? So, for example, you are creating a class for a university. The name of the university may not, the name of the university may be static because you're just putting the students in there and you do not want that to change. And for all the students, you want to have one university name. You will name it static so that for all the objects of a class, for example, you created a class student and you created 10 objects of that, all those 10 of objects will have the same static member, which is gonna be called a university name, which can be any university. Okay, static class. This is just a basic explanation that I thought I gave you. Shared by all objects of a class, efficient. When a single copy of data is enough, only the static variable has to be updated. May seem like global variables, but have class scope, only accessible to objects same class. But they will seem like global variables. You might have learned about global variables by now, but these are class scope. Class scope basically means once the class ends, no other class can access these static members. Only the objects of the same class can access these static class members. Initialized at file scope exist even if this will exist even if no object exists. So you can use by class name. The both variables and functions can be static, can be public, private, protected. You can make them anything. They can be either public, they can be either private, they can be either protected. Two-step procedure. First of all, you will declare them inside. For example, you basically declare them static int radius. That is the syntax of this. This is the syntax of this. Then you basically define them outside. Declare them inside the class, define them outside. This is a syntax that has been written for you. I hope that all of these codes are understandable to you and visible to you. And this basically int circle is basically that you have just set a default value. You can even set this to 0, doesn't matter. But this is just a default value for this. Static variable initialization, default initialization 0 or null or initialized to user or defined value. Initialization just made once at compile time. It will be initialized only once at the compile time. Public static class members that can be used using class name, any object of the class. They can be accessed via non-static member functions. Even non-static member functions can call them. Can be accessed via static member functions. Obviously, can be accessed through that. Private static class variables cannot be accessed through the class name. They can never be accessed through the class objects, but they can be accessed through non-static member functions and static member functions. Static class functions. Okay, as we have static member functions, in the similar manner, we have static class functions as well. What is a non-static function? Can access static, non-static data members and static, non-static methods. Okay, non-static function can only access any data members. They can access either the data members which are non-static, which are static. Static functions can access static data and static functions only. They will never be able to access the non-static data members. Okay, public static class functions, classes can be used to call them, objects can be used to call them. Private, they can never be used calling the class name or the object name. They can be used using the static member functions or non-static member functions. This is another example for you. I have created this example for you. Again, you have the example of static int get count. You made a member variable of static int count. For here, you might have noticed that you did not initialize it outside the class, so the default value is 0 for this. So now, whenever in this case, right, I have defined it over here, but if I did not define it, the default value will always have been 0. So now in this case, for example, whenever you created the static variable, it can be used to keep a count, but every time it will show that this is the value. So in the constructor, I can show you, okay, now what are we basically doing? We are basically using this count variable, the static count variable, to retain a count at how many objects are basically in this class. So for example, whenever I create an employee object in the constructor, it will increment the count variable, the static count variable, which will then be accessible to every object of the class. The basically the class employee, and you can basically print it that how many objects you have created. So this is something in the destructor we're basically decrementing, because once you delete an employee, it does not no longer exist. And this is how you're basically using it. You have different examples using a pointer dynamically allocated in your memory. I've already discussed this with you. And then you can use the arrow notation or the dot notation, any notation that you prefer. And this is how the static member variables are used. Okay, this is something you have used. Number of employees before you did anything was 0, and then after this was 2. Once you deleted deleted them, then they were again 0. Constant objects. Object data members can only be read. Okay, this is something which can only be read. You can only initialize these at once. That is when you are initializing an object. For example, you created a constructor. At that point, you can basically initialize this. Okay, the best example at the runtime I can think of a constant object is basically the model of a car. For example, you bought a car. But nowadays, you can change the color of the car by using any sheet. You can change anything of the car, but you cannot change the model of the car. The model of the car will always remain same. So whenever you will initialize that car, you will have a constant object called model, and that will be model 18, model 19, whatever, and that can never be rewritten or updated. Okay, so the constructors and destructors can modify the object. Constant property of an object goes into effect after the constructor finishes executing and ends before the class destructor executes. So once the constructor finishes, then your object is updated. You can also have constant member functions as well. You have the constant objects, then you have the constant member functions. Constant members and references must be initialized using member initializer. Member initializer list is something I will show you in the code example as well. I have that in this basically slide as well. This keyword is a special built-in pointer, constant pointer that references the calling object. So this pointer is something which is a default, you can say, keyword in C++, which is used to call the reference of the calling object. This pointer is passed as a hidden argument to all non-static member functions. Remember, it is only called in non-static member functions and is available as a local variable within the body of all non-static functions. Not part of the object itself. This pointer is not reflective with size of object. Can be used to access instance variables with constructors and member functions. So basically, you can access the different data variables, the data members using this pointer. So you can say this dot name is equal to whatever you're initializing in the constructor list. So for example, this is your examples using this for a member function to access data member X. So for example, you had a class, say area, and in that you had a member function radius. So obviously you can access it through radius, but you can also access it through this dot radius, or basically this notation, this arrow radius, or basically uh, pointer to asterisk to this dot x. You can use from this, and you can also return the member variable function this, and this is using this pointer. Example of cascaded member function calls. This is just an example for you. If you want to study this, you can use these slides and you will understand this concept. But as I repeated, the basic concept for the classes and objects, and hopefully you have understood them by now. Okay, you execute the set hour, return this reference to the object and the expression. So what happens basically is that this is something you are setting. The set hour, set minute, set second. So once this gets set, it returns a reference to the object to set minute, which gets that reference and then sets it, and that gets this reference, and then that sets the value for this. This is just a simple explanation that I have given to you. And this is something that you have done. Now, an example for you, you have already, I'm hoping you must have already known about this object, is just using the same notations for you. I will prefer the arrow notation, but it's up to you, whatever notation you want to choose. Okay, an example, another functions for you. This is another coding function for you. And then you basically have this another these all are included for your help so that you understand them. Okay, we have the member initializer list. Can be used to initialize both constant non-constant data members. It can be used to initialize any constant non-constant data members. Constant members and references must be initialized using, okay, something that you have to understand in C++. Once you create a constant data member, whether it is the gender, whether it is the model of the car, you have to initialize it in the member initialize list. So that is basically this syntax. That's this syntax over here. Syntax you see over here, you have to initialize in the member initializer list. Only then you will be able to initialize your reference objects or your constant data members, and you have done that over here. You can see you, oh, and obviously you can use that to initialize any non-static constant members or static constant members, or basically your non-static functions or normal non-constant members. But it is important for these references and the constant member function that you use them, the constant objects. Okay. Yes, initialize list. You have already used the parameter name, same as data member. This is something I've given you the code. Now we will go to the practice section, and I hope that you understood this lecture on the level, on the basic level I wanted you to understand.